Mendeleev's periodic table. In order to make a proper study of elements, they should be systematically classified. In 1869, the Russian chemist Dmitry Ivanovich Mendeleev published the first successful classification of elements. Mendeleev noted that the repeating patterns of behavior of elements could be arranged in a sequence Mendeleev arranged the elements in the order of increasing atomic weight from left to right, in rows, and from top to bottom in groups. In this arrangement, elements that most closely resemble each other tend to fall in the same vertical group. This group similarly recurs periodically once in each row, and the tabular format is known as periodic table. Watch carefully the filling up of elements in the periodic table. H. Hydrogen, atomic weight 1. Li. Lithium, atomic weight 7. Be. Beryllium, atomic weight 9. B. Boron, atomic weight 11. C. Carbon, atomic weight 12. N. Nitrogen, atomic weight 14. O. Oxygen, atomic weight 16. F. Fluorine, atomic weight 19. Na. Sodium, atomic weight 23. Mg. Magnesium, atomic weight 24. Al. Aluminium, atomic weight 27. Si. Silicon, atomic weight 28. P. Phosphorus, atomic weight 31. S. Sulfur, atomic weight 32. Cl. Chlorine, atomic weight 35.5. K. Potassium, atomic weight 39. In this way, the other elements too were given places in this periodic table. Mendeleev placed some elements out of order, that is, not in the strict order of increasing atomic weight. For example, Mendeleev placed tellurium, atomic weight 127.6, ahead of iodine, atomic weight 126.9, so that tellurium would be in the same column as sulfur and selenium, elements that closely resemble it. Mendeleev left gaps in his table. This was done to avoid expectations to the idea that elements with similar properties fall in the same vertical group. Instead of seeing these gaps as defects, he boldly predicted the existence of undiscovered elements. Furthermore, because the table was based on patterns of properties, he was able to predict some properties of the missing elements. For example, he left a blank space for an undiscovered element that he called Eka silicon and used its location between silicon and tin to predict an atomic weight of 72 and other properties. Table shows just how accurate his predictions were. When compared to the properties of the actual element, germanium, discovered 15 years later. Table shows just how accurate his predictions were. When compared to the properties of the actual element, germanium, discovered 15 years later. Thus Mendeleev's periodic table, although not used anymore, formed the basis of the modern periodic table. The predictive nature of Mendeleev's periodic table led to its wide acceptance as a tremendous scientific accomplishment. He postulated a law called as periodic law, which states that the physical and chemical properties of elements are periodic functions of their atomic weight or mass. Click on the buttons provided to learn about the conclusions and demerits of Mendeleev's classification.